vertical විදිහට තියෙනවා වගේ. එහෙම object එකක් තියෙන මේ AB axis එක vertical. يعني center of gravity මේ AB axis එකේ කොහෙද දැනක තියෙන්න ඕනේ. Right. Then when a mass M is attached to point B, mass එක මෙතෙන්ට attach කරනවා. අයගත්තා කියලා. right. So කලින් the mass එකක් මෙතෙන්ට B වලට attach කරනවා. එහෙම attach කරොත් එහෙම දැන් කලින් center of gravity තිබ්බේ මේ වගේ point එකක නම් දැන් center of gravity මොකද වෙන්න ඕනේ? පල්ලෙහාට යන්න. නියුගේ කොහෙද පැත්තට යනවා? හරි. දැන් ඊට පස්සේ මෙයාව suspend කරනවලු C වලින්. අතන CD axis එක නෑ. ඒක ඕවලින් තමයි කැපෙන්නේ. ඒ කියන්නේ දැන් අතන center of gravity තියෙන්නේ මේ axis එකේ කොහෙද තැනකට තියෙන්නේ නේද? ඒකයි මේකයි කැපෙන අතර මෙතන තමයි mass එක suspend කරලා center of gravity මෙතන තියෙන්නේ. හරි. ඒතර අහන්නේ the center of gravity of the plate is plate එක කොහෙද ඒක center of gravity තියෙන්න ඕනේ? TGP මෙතන කලින් පටන් ගන්න. එහෙනම් in between A and O කොහෙද තැනක තියෙන්නේ? notice. in between A and O තියෙනවා mass එක suspend කරාම මේක පල්ලෙහාට එනවා. පල්ලෙහාට ආවට පස්සේ මේ CD line එකකින් center point එක center of gravity ඇවිල්ලා තියෙනවා. the mass එක අයින් කරා නම් එනවා මේ point එක ආයි ඒ line එක උඩට යන්න ඕනේ. එහෙනම් answer stay in between A and O. Yeah. Yeah. Right, question number 11. A thin plate of irregular shape is shown in figure, hanging freely from the point capital AB, A by means of string. After that, it's hung freely from point B, as shown in figure. The point where the center of gravity of plate is. මේක ඔයාට කරන්න වෙන්නේ ඒක මෙහෙම එනවා A dash line එක ඇඳගත්තා. center of gravity A dash line එකේනේ. ඊට පස්සේ second figure එකේ තියෙන මේක මේ පොඩි construction එක කරන මේක පොඩක් මේ අඳින්න වෙනවා. A dash is slide. ඊට පස්සේ B වලින් එක ලං කරාම එයාගේ vertical line එක මෙහෙම ඇඳ ගන්න වෙනවා. ඒ දෙක cross කරන point එක තමයි center of gravity තියෙන්නේ. මොකද එන්නේ? S නේ. S එක cross කරන දාන්න S නේ. cross එක S වල. හරි හරි. Oh, right. Yeah. Center of gravity, the first figure. This must be lines on some of the vertical A dash, right? So now we then lines. B and construct the vertical line B. Both legs are here. The center is perfect. Right, although into that gun, for that float break, then may 20 minutes and 6. 35, 6:35, 6:35 පටන් ගමු. ටක් ගාලා එන්න. අද 8:30 ඉවර කරනවා. ඒක නිසා එන්න ටක් ගාලා මේ අද සෙන්ටර් ඔෆ් ග්‍රැවිටි තමයි කරන්නේ. මොකද දුන්නන්නේ කවුන්ට් කරන්නේ. Like finished. Further, no question. Let's see. I got it. Right. Question number 7. It was question number 7. Mogada answer 7. C. Question number 7 or C the answer. C. Are the agree there? No C. Me the number. Are the C the answer? 7. C. Right. Question number 8. Question number 8. B. B. Question number 8 का बालन का 8 में देखिए मेहम पार्ट है उनका तो आंसर दो यस right make a man a uniform y is bent as shown in figure the point most likely to be the location of the center of gravity the main the center of gravity मैं point w मैं आगे मतलब मैं आगे common result में कहती है ना मैं था वो डाल दी है ना center of gravity के दिन system में के 2:1 ratio कटा मैं distance है वैसे नॉन 2:1 मैं आगे point लेकर चल रहा हूँ क्या ने it cannot B क्या में point है B में कर E में था C and D रहती है ना yeah A has that point A तेरे बड़ा पूरा नहीं है
Like how can we like specifically say that that place has the weight
that place
has the weight from where
the right and the middle point the weight of this part is the part of the wire acts at on the middle point yeah because it is a uniform rod the wire का एक center के दिखा इधर so center is in level with the center is at the same horizontal level with B B तक का level लेके थी right so center of gravity must be at in between B and E and it must be close to B so the accurate question is C මොකද මෙතන weight එක වැඩිනේ උඩට යන්න ඕන C is the most suitable point right question number 16 वाला का होगा question number 16 මොනවද F क्या करने A 60 8 का 8 का 8 का C 60 C there C ठीक है C right वाला तो मे पार्ट्स लेके सेंटर ऑफ ग्रेविटी इससे में है W W නේ ඒ දෙකේ common center of gravity එක තියෙන්නේ මෙතන හරියට මැද මේ දෙන්නගේ W common center of gravity එක 2W මේ දෙන්නගේ 2W නේ center of gravity තියෙන right at the center 4W හරි ඊට පස්සේ මෙතන එක කෙනෙක් ඉන්නවනේ එයා මොකක් ගත්තේ නෑනේ මෙයා W දැන් එතකොට මෙන්න මේ distance එක center of gravity තියෙන්න ඕනේ මෙන්න මේ space එකේ තියෙන්න ඕනේ මෙන්න මේ ටිකේ මෙන්න මේ space එකේ තියෙන්න ඕනේ මම චුට්ටක් මතක් කරමු මේ distance එක with the ratio එකෙන් ඕනේ center of gravity එකෙන් 4 to 1 මෙයා 4W මෙයා W 4 to 1 ඒ කියන්නේ මෙයාට close වෙන්න ඕනේ මේ line එකට පල්ලෙහෙන් වගේ තියෙන මෙයාට කිට් වෙන තියෙන මෙන්න මේ වගේ point එක වෙන්න ඕනේ 5W වෙන්න ඕනේ එතකොට C වගේ තමයි නේ C කියලා ගන්න C 19 is it D capital D 19 નો D නේද නැද්ද C 19 වල බලන්න මෙයාගේ weight එක W මේ තුන් දෙනාගේම common CJ එක තියෙන මෙතන 3W මේ parts දෙකේ CJ තියෙන මෙතන W මේක 2W common CJ එක මෙතන තියෙන්නේ center of gravity එක system එකේ තියෙනවනේ මෙන්න මේ gap එක නැත්නම් මේ distance එක 3 to 2 ratio එකට ඉවර. ඒ කියන්නේ මේකේ half way නෙවෙයි කියලා පොට්ටක් විතර කුඩි ඔය හැකිත. ඒක අපිට යන්න ඕනේ. Best is D I think. Best is 10. D එක තමයි කරන්නේ. උඩට ඉල්ලපෙ. D capital D. C එක ටිකක් C B එක කරන්න. C එක ටිකක් මේ වගේ තැනක තියෙන්නේ. C එක අපිට තියෙන්නේ එච්චර යන්න බෑ B කියන්නේ. B කියන්නේ මේ පොයින්ට් එකනේ. B is here. E මෙතන 3 to 2 ratio. එතකොට මේ වගේ වෙන්න බෑනේ. මේ පැත්තට එන්නේ. මේ පැත්ත ගෑප් එක වැඩි වෙනවද පොඩි. මේක බෙදෙන්න ඕනේ 2 to 3. මේ distance එක CJ එකෙන් මේ distance එක 3 වෙන්න ඕනේ. මේක 2 වෙනවා. පහෙන් 3ක් මේකෙන් පහෙන් 2ක් ශේෂ. එහෙනම් බෙදෙන්න ඕනේ. ඒතර C කියන එක නා beta cross. C කියන එක නා point එක C කියන්නේ මෙන්න මේ වගේ point එකක්. ඒතර එහෙනම් මේක වෙනස් වෙනවා. මේක නා 2 to 3 වගේ. Right. Question number 20. C. B, ne? B. Question number 20. B. The main center of gravity මෙතන තියෙන්නේ. 3W. මේ part එකේ center of gravity A වල වගේ තියෙනවා. W. එහෙනම් මේ distance එක 3 to 1 ratio එකට බෙදෙන්න ඕනේ. So C වගේ තමයි මේ point එක. හරි මැදදී F. මේක B වෙනවා. Hey, this one weight of this part is W. This one is W. This one is W. The common center of gravity is here. The total weight is 3W. 27. अब यार करबू आए का वही करने होगा देना नहीं किसी C ने right ඊළඟට බලන්න Right, question number 10. Question number 10, 13. Marker. Question number 10, 13, 17. 13 කියන්නේ අර මේ කොහෙද? 12. පළවෙනි 13 අර the person bends down as shown in 13 දෙකම හදන්න ප්‍රශ්න. 13 දෙකම හදන්න. 13 දෙකම හදන්න. 13 දෙකයි 14 දෙකත් නෑ. හරි මං කියන්නේ 13 17 ඊළඟට 24 more doubt ඇතිය මොකද මේකද මේකද මේක කර 16 में කලින් කරේ අපි කරේ 8 කරා 8 කරා ඊට පස්සේ 16 කරා 8 එක 860 7 860 28 උත් හදන්න 28
I don't know when Bangladesh is the sound they were saying that so I probably this color that what do you want?
Question number 10. Question number 10. Answer B. Is it B? D. E.
B.
B. It is ED. It is ED. Answer A क्या लगाऊं? Answer is A. Ne, B. 1, 2, B. C. C. D. D. E. E. Right. Betul lihat dia, no? Hebat. Kami. Kami memang antara orang yang gimana? Memang strings negatif ni memang hoती Right. So now this rod is at equilibrium under three forces. अभी तो हम equilibrium करें हैं, but mega forces तो लगी तमाई equilibrium में थी. What are the forces? Tensions of the strings. The third one is weight. But हरिटा दें, और equilibrium के तीन नंबर under three forces, एक तीन वाक तीन देगा. Forces तो लगी में equilibrium मैंने वाला नहीं है बात. ये forces तो ना भी तो मैं कभी पास करता है ना. ये forces तो लगी under three forces. If the body is at the equilibrium under three forces, those three forces are meets at the point. Definitely it should meet at the point. एक तरह के ध्यान में रखना है. नहीं? ऐना में tension ने के line of action ने का, ये मानो हम आप ये extend करें line of action ने के tension ने का. नहीं tension ने के line of action ने का, स्पराट ना, में point लगा, मैं वैसे का point लगा, और मैं क्या नहीं make line of action लगा, पर मैं forces ने के बेहतर हम लोग. Now what is the third force? Weight. The line of action of the weight also goes through this point. है ना? मैं दिन हम भी ना point है हरा, नहीं बा? Weight के लिए line of action है क्या करना? अन्य point के तो भाई center of gravity. एक workout का लगा हम लोग करना. तो B और D बात तो शिफ्ट है. Kalau mainan di dia di sana ya. Kalau aku lihat ini, aku boleh lihat kalau this active terkait motor. Right. Question number 13. 13. 13 के बाद आंसर A B C D हाँ E B ने sama hilang inna kodna eka me hari tamai tiyenne point ekane तर මේක shape එක වෙනස් වුණාම මොකද දැන් මේක අහුල් දෙකක් අල්ලගෙන center of gravity එක body එකකින් එළියට යනවා. It is B. Correct answer is B. Sorry. The second, the The coordinates of the center of gravity of the uniform hardboard plate shown in the figure A is x0, y0. Now shown in the figure B, plate is folded along the OP. If the coordinates of the center of gravity of the folded plate is x and y. මේකේ ඉන්ඩිවිඩුවල්ස් ටිකක් දීලා තියෙන්නේ මොකද්ද correct answer එක? ඒක answers පහේ ගන්න. තේරුන්නේ නැහැ කියලා ගන්න. I think it to be printed. Huh? එකම answer එක? Which one? එහෙනම් මේක මාර්ක් කරගන්න. ඒක නෙවෙයි ද answer. බලමු. right මොකද මේ කියන්නේ? මේ වගේ මේ right. බලමු. මේක මෙහෙම shape එකක් තියෙන්නේ. The question says center of gravity is x naught y naught ने folded along the OP line එක cover කරා. දැන් මේ parts දෙකේ center of gravity ගත්තොත් දැන් මේ part එකේ center of gravity මෙන්න මේ වගේ point එක තියෙන්නේ. මේකේ නිකන් මේ වගේ point එක. common center of gravity එක තියෙනවනේ මේ line එකේ කොහෙද තැනක මැද වගේ තැනක නිකන් guess කරගත්තොත් කොහෙද අපි මේ වගේ OP මේ තැන කොහෙද තැන තියෙන්නේ. එහෙම යන්නේ නැහැ. මේ පොඩ්ඩක් මෙහෙට නෝ මෙයා කොහොමද පවන්නේ මේ වර්තනක තියෙන්නේ. දැන් මේක fold කරනවා. මේක fold කරන එක දැන් මේ OP line එක මේ fold කරනවා. දැන් තියෙනවා shape එක මෙහෙම එකක්. next shape එක කොහොමද? දැන් කලින් center of gravity coordinate තමයි x naught y naught. ඒතර fold කරාම center of gravity එක මොකද වෙන්නේ ඕනේ? height එක ගත්තොත් දැන් center of gravity මේ shape එකේ තියෙන්නේ ඔය මේ වගේ point එකකනේ. නේ? මේකේ x coordinate එක තමයි, ඒ කියන්නේ මෙන්න මේ coordinate එක. මේක තමයි x කියන්නේ. මේ height එක තමයි y කියන්නේ. මේකත් එක්ක compare කරන්න. දැන් කලින් x naught කියන්නේ මේ distance එක x naught. දැන් x එක center of gravity පොඩ්ඩක් දකුණු පැත්තට ගිහලා තියෙන්නේ. ඒ කියන්නේ new center of gravity, x coordinate of the new center of gravity is greater than previous x coordinate, greater than y coordinate. So y is less than previous coordinate y. ආන්සර් එකක් දෙන්න දෙකේ. ඒක තමයි 3 4 එකක් තිබුණේ. ඒක 4 වෙනි එකනේ 3 දෙකේද? ඒ මාර්ක් කරගන්න එකක් හදාගන්න. 4 හදාගන්න. x greater x naught y lesser y naught. 70 next 70 answer background क्या E is now in the part of the circle like a कोई ना अपना मेरा answer सुखी है पर यार भाई right 17 भाई next 24 24 करा था अभी 24 करा है आपका आंसर 24 feet drops of water flow from a tap at a constant rate as shown in the figure. The center of gravity of the system of water droplets in air is almost like to be at. हमारी बताना नहीं भैया drops की आती है ना काय देखा तो can we have drops right center of gravity पे हिट then बालन में के mass distribution ने क्या නේ මේ පැත්තේ තියෙන gap එක අනුව ඉන්නේ distribution එක වැඩි. ඒ කියන්නේ හරියම right hand center කියන්නේ මේ හරිය. center එක කියන්නේ REZ center. Right? So center of gravity of these five droplets must be at above the R. It can't be P. P is too much above, above. Right? And it must be in between P and R. The only point is given is Q. Q is the answer. Q is the answer. Okay, 28 करा उसने. 28 question करा from the. No. करेंगे. ना वहाँ पे brain को stay होगा ना नहीं. नहीं. Right. So, answer for 28. 20 R. R. All values with R there. 28 R. Come. Say. On it. Can't be R. R in the van. How it can be R? Hey, Bala. The composite object shown in figure is made by connecting four rings A, B, C, and D of radii R, 2R, 2R, and 3R, respectively, made from a uniform metal wire. The distance from point X to the center of gravity of the composite object is. And we equal to name more. What do you think? Center of gravity X is not given distance and R. Radius from R, 2R, R. Right. So let's take the weight of this small ring is W. Weight of the small ring is W. Right? So the center of gravity of this small ring is at this point. A simple R distance left to the point X, it is W. If the weight of this small ring is W, so what is the weight of this medium size ring of R 2R radius in terms of W? May W no make a weight take in terms of W, two times. All these rings are made with same kind of wire. එකම ජාතිය wire එකකින් හදලා තියෙන්නේ. ring එකෙන් හදලා තියෙන එකම ජාතිය මිදුළු එකකින්. So weight for unit length is constant for all these rings. එහෙනම් මෙයාගේ weight එක එන්නේ මෙයාගේ මේකේ circumference එක 2πr. 2πr length එක weight එක W. W is weight W is for the 2πr length. The length or circumference of this circle of radius 2r is 4πr. Then 2 times of 2w. Weight of this large circle 6πr is 3w. 3w. එහෙනම් බලන්න මේ දෙන්නගේ weights දෙක. මෙයාගේ හරියටම center එකෙන් තියෙනවා 2w. This is 2w. මෙයාගේ weight එක 3w. 3w කියන්නේ දැන් අහන්න මේ සිස්ටම් එකේම center of gravity වලට x නම් දෙන distance එක. දැන් චුට්ටක් ඔයා බලුවොත් එහෙම these two rings are identical. So center of gravity of common center of gravity of these two rings must be at x. Must be at x. 4W is at X. So you can remove these two rings now. You can remove these two rings from your side. Now this figure is reduced to two rings. One is smaller one and second one is bigger one. So suppose the center of gravity of the system is at somewhere at here. Total weight is 4W, W, 3W, 8W, isn't it? 8W, 5, 8. Right. So distance from X to the center of gravity, take it as a simple A. Simple A distance. Distance here simple R. Distance to the 3W. Make a distance again. 3R. Now take moments about X. Take moments about X. Taking moments about X. Right? Moments from the system. 8W into A. Make a system again for this set. System again weight again 8W. In a moment from 8W around X is 8WX must be equal to the moment from W into R plus moment from 3W. 3W into 3R. W cancels. R into 9R, 10R over 8 is X. X is 5R over 4. Is this an answer of 5R over 4? Yes. So answer is 5R over 4. Answer is 5R over 4. How was answer? No. Question number 14. Final one. Question number 14, final one. 14. 14. 14. All these questions are past paper questions. Right? So we're going to make a past paper solo level questions. Practice कराओ ठीक है not it. Okay. Answer? Yes. Yes. And the object of the capital H shown in figure is hung from point B. Point B is L1. It is positioned so that point D is directly below it, B. You can make a vertical line between D and B. The center of gravity being known somewhere in between B and D on this line BD. BD line के लिए आप किसी ने लेकर हमें तो हमारा make a vertical line के लिए ना center of gravity के line के लिए तो. But when the object is hung from point E is it is positioned so that point C is directly below it. Yeah, make a measuring hand karama. Main line like a vertical line like. So center of gravity of this shape is should be at the intersect point here. It is close to S. Right. Through questions to complete karana. Last week අපිට essay paper එකක් තියෙනවනේ brain boost 18 එකේ essay question එකක් තියෙනවා නේද අපි? Sorry. Can you? Sorry, I didn't get it. Can you repeat?
And we should be
So you can message this company about message right want pay go pay ऐसे question है आती है ना तब पे अब इसमें क्या है question answers question number 1 discuss करा. Right, question number 2. Question number 2. Brain boost paper 18. Question number 2. You know the 18. Right. An ice skater capital A of total mass 65 kilograms, including his helmet, slides freely on frictionless frozen lake in a straight line with a velocity of 2 meters per second. Right. So this is the ice skater. Mass is 65. Like when Sadaka North London. He is moving in 2 meters per second. Velocity in a straight line while he is moving, he throws his helmet weighing 5 kilograms horizontally with a velocity of 4. Now he throws his helmet with his 5 kilograms with a velocity of 4 meters per second. Yeah, I want to visit Karamaya. Right. So after throwing this helmet, this ice skater's direction of moving and his velocity get changed. So final velocity of the ice skater towards the initial direction of his moving v1, and he has a velocity component, the direction normal to the initial moving direction. Take it as v2, and also this helmet also has a velocity component along the moving direction of ice skater, which is same as ice skater's initial velocity. දැන් මෙයා helmet එක මෙහෙම යනවා විසික් කරනවා. විසික් කරලා helmet එක ice skater ගේ velocity එකම තියෙන මේ පැත්තට. නේ? ඒතර මේ පැත්තට extra velocity එකක් යනවා 4 meters per second. The ice skater ගේ direction එක moving direction එක change වෙනවා. එයා මෙහෙට යන්නේ. So this velocity has two components. One is along the initial moving direction v1. The second one is normal to the direction v2. Resultant is v dash. V dash. Right. Question. The first question asks, find the magnitude of the resultant velocity of capital A. A is this. After throwing the helmet. So question asks resultant velocity. Resultant velocity has two components, v1 and v2. Then we should find v1 and v2. So what are the principles we can use here? We can use conservation of linear momentum principle, right? So we are going to apply conservation of linear momentum towards the direction of ice skater initially moved and direction normal to that initial moving direction. Yeah, moving in a normal direction එකටයි ඒ පැත්තරයි තමයි conservation of linear momentum දාන්න. So from conservation of linear momentum principle, initial velocity momentum of the ice skater and the helmet is 65 into 2. Momentum is mass into velocity. Direction, the final momentum of the ice skater, he released the helmet. Helmet is weighing 5 kilograms. With the helmet, the total mass of the ice skater and helmet is 65. So after he released the helmet, his mass is now 60. So ice skater's momentum along the direction of his initial moving is 60 into v1. And also this helmet has a momentum towards that direction, which is 5 into 2. So 130, 60 v1 plus 10. And then we had 120, 60 v1. v1 means 2. And this is not the final answer. Question asks what is v dash. So we need to find v2 also. Right. Again, apply conservation of linear momentum along direction normal to the initial moving direction. So initially ice skater's momentum along the direction is 0. A path velocity ka nahi, it is 0. Right. The final momentum of the ice skater along the direction, the velocity, the direction of the velocity is now is opposite to the direction we choose. So that is negative momentum 60 into v2. The momentum of the helmet, to the same direction of V2. So 5 into 4. 60 V2 is equal to 20. V2 is 20 over 60. 1 over 3, 0.33. The resultant velocity V dash is V1 squared plus V2 square root. 2 squared, 0.33 square. Square root take that. This is the final answer. Direction එක අහන්නේ නේද? Find the magnitude of the resultant velocity. Only magnitude. Find the resultant. Okay, 2 point ගන්න find කීයද? 0.66. 2.066. Can't be. 2 squared is 4.
0.33 square is 0.1.
Zero point three three squared. 0.33 square is 0.108. So this is 4 plus 0.108 square root. So 4.108 square root. Two point zero two. 2.02. 03 okay. 226 okay. 2.02. Right. Second part. Another scalar capital B of mass 45 kilogram sliding freely in the opposite direction on a nearby parallel course with a velocity 1 meters per second. Catch the helmet thrown by A. Another skater is moving the direction opposite to the first skater with a velocity of 1 meters per second. His mass is 45 kilograms. Now helmet is moving with 4 meters per second and there's another component 2 meters per second. This skater B catch this helmet. Now the total mass of the skater B and helmet is 50. So what would be the direction of motion after catch the helmet? එයාට මේ පැත්තටම යන්න පුළුවන්ද? No. Right? So initially this helmet has a momentum towards direction normal to the direction of motion of B. මෙයා යන පැත්තට අනිත් පැත්තට momentum එකක් තියෙනවා. ඒ නිසා මේ momentum එක conserve වෙන්න ඕනේ. So therefore after catching the helmet, the ice skater B should have a velocity towards this direction. We take it as V3. And he also should have a velocity towards his original moving direction, which can be 1. Take it as V4. Right. Now again apply conservation of linear momentum. Conservation of linear momentum principle to horizontal to the direction the left right. So initial momentum of the ice skater B is 45 into 1 and the helmet has a momentum. The direction of velocity is now opposite to direction of the direction of B is moving. So it is negative 5 into 2 negative. The final momentum is, the mass is 50, velocity V4, 45 minus 10, 35, 50 V4, V4 is 35 over 50, 0.7. Now it is in perpendicular direction negative. Initially, ice skaters' momentum to the perpendicular direction is 0. Momentum of the helmet is 5 into 4. Final momentum of the ice skater and the helmet is 50 V3. So V3 is 20 over 50, which is 0.4. Right. Part 2 okay. So answer for part simple A is this. The original direction of the motion of B, right? Direction perpendicular to the original direction of motion of B. Part A and answers to the part A and B. 0.7 and 0.4. So this is a past paper question. I think it is the mechanics question in the paper, I think 1995 or 1997. 5 months. 5. Somehow the previous slide again, rather than question again. Over 7 cut, 7 cut, 8 cut, 10 years, 1 year. 9, 5 and 12 years. 1 year, I will rather than question. Right. Calculate the total kinetic energy of the helmet and the skater B just before B catches the helmet. So kinetic energy at this situation, just before he catches the helmet. Right. Question number, Roman number 3. Total kinetic energy of the helmet and the skater. Total kinetic energy of the skater B and the helmet. Right. So total kinetic energy of the skater is half into 45 into 1 square. Kinetic energy of helmet, it has 2 velocities. Either you can get the resultant of those 2 velocities, or you can treat them separately. Half mass of the helmet is 5. But kinetic energy towards the direction of kinetic energy of the helmet to the direction is half into 5 to 2 square. And kinetic energy due to this velocity, half into 5 into 4 square. Right? Instead of writing like this, you can get this half into 5 out from the brackets, and you can write like this. Velocity components are in Ghana. Why? 45 again? Half into 5, why? No. Initial kinetic energy of skater and helmet. This one is the initial kinetic energy of the skater. Its mass is 45. So you can get that. Oh, I can sampurna camera gattu. Right. So 45 divided by 2, 22.5. 2 square is 4. 4 square is 16. 16 plus 4 is 20. 20 divided by 2 is 10. 10 into 5 is 50. So total kinetic energy is 72.5 joules. 72.5. 72.5. Right. Answer is correct. How they can? Good. Calculate also the total kinetic energy of the helmet and the skater P after we catch the helmet. After he catch the helmet, the velocities are up here 0.4 and 0.7. So kinetic energy after half mass of the helmet and the skater is 50 now. Composite object එක ගන්න helmet එකත් අල්ලගෙන නේ දෙන්නගේ mass එක ගන්නකොට එකට. The velocity one component is 0.7 v squared 0.7 squared. The other component 0.7 squared. One six 0.65 into 25. 65 divided by 4. 16.25, I think. 16.25. The final kinetic energy is 16.25. Hello? No. Right. Explain briefly why the two values calculated in part 3 and 4 above are different. Right? The initial kinetic energy of the helmet and the skate is 72.5. After he catches the helmet, the total kinetic energy has reduced to 16.25. So what is the reason for that? What happened to that energy? 72.5 minus 16.25, nearly 56 joules has been lost due to what? Mudradin helmet catch karnakoda, that the energy loss is due to, it may be converted into sound and heat. Helmet අල්ලගත්ත ගමන් පොඩි heat එකක් generate වෙන්න පුළුවන් නේ ඒ වගේම sound එක සද්දය ඇහෙන්න පුළුවන්. That loss of energy has converted into sound and heat energy. That is the reason. Right? Explain briefly why the two values calculated 3 and 4 above are different, because energy has lost and convert that energy into the sound and heat. Energy has transformed, the loss of kinetic energy has transformed, to energy forms as heat and sound. Whenever in the band, heat and sound. Light and එළියක් එන්න ඒවන ගින්දරක් එහෙම නැහැ light. Finally, after some time, the helmet falls off freely from the skater. What will happen to the velocity of P? And now he's moving with the helmet and suddenly he lost helmet. He lost the helmet and falls it freely. So what happens to the velocity of B? Now he's not drawing the helmet. Does it freely drops? Does it affect to the speed of the skater? No, because when the helmet is released, there's no velocity towards the downward direction. Velocity is 0. It only has the same velocity as the ice skater has at the direction of moving. Right? So මේ අතර වෙලාවේ ice skater helmet එක අතාරින්න මෙයා මෙහෙම velocity එක යන ගමන් වක්කරියකින් හෙල්මට් එක ඩ්‍රොප් වෙනකොට හෙල්මට් එක නම් තියෙන්නේ මේ පැත්තට වෙලොසිටි එකක්. මේ වෙලොසිටි එකම තමයි තියෙන්නේ. මේ පැත්ත වෙලොසිටි එකක් නැහැ. නේ මෙයා රිලීස් වුණාට පස්සේ මෙයාට එන මොමන්ටම් කම්පොනන්ට් එකක් එන්න බෑ. ඩිරෙක්ෂන් එකනේ. total momentum conserve වෙන්න ඕනේ. තේරෙනවද? එහෙනම් velocity of ice skater does not change because what will happen to the velocity of B? Remain same. Because total momentum must be conserved. When the helmet freely falls, there's no velocity. So there's a zero velocity along the downward direction, the downward direction of the helmet falls. When the helmet freely falls, the initial velocity of the helmet on the direction of falling is zero. Since the total momentum should be conserved, the velocity of the skater B remain at same value. The remain same. Right. MCQ paper එකේ පොඩි ඩවුට් තියෙනවනේ. පළවෙනි පහවත් කරලා නැත්නම් hard questions බලන්න ඊට බලන්න. Like question number 1. Paper 90. ඔයාලගේ ස්කෝලේ තියෙනවද මේ දවස්වල නිවාඩු වෙකේෂන්ද? ආයෙ කියන්නේ අපිට ඉවිනිං ක්ලාස් එකෙන් දිගටම කන්ටිනියු වෙන්නේ. මොකද අපේ ගවර්න්මන්ට් ස්කූල් වැකේෂන් නේ. ඒතකොට අපිට next week Friday මේ නිවාඩු වෙන උදේ ක්ලාස් එකක් කරන්න ඔයගොල්ලෝ ස්කූල් සිනවනේ. කට් කරන්න එපා. අනිත් ඇයට කොහොමද දන්නේ අපේ ෂාප් ස්කූල් දිනවනේ. අයන අපේ ඉවිනිං කරමුනේ ක්ලාස් එක. අද වෙන්න ඕනේ නැහැ. ඔයගොල්ලෝ පිටනේ ස්කූල්. Right. Question number 1. Angular displacement theta is given by k alpha t square. Alpha is angular acceleration, t is time. Dimensions of k. Theta equals k alpha t square. Dimensions of k is dimensions of theta over alpha t square. What is the dimension of theta? Angular displacement. Dimension? Radians. Dimensions. Radian is the unit of the angulation. So it does not have a dimension. Angular dimension and radians. Angular dimension and that. Dimension is 0. So dimension is dimension is 0. Theta. So alpha is angular acceleration. Dimension is t. Dimension is -2. Right. Yeah. T square. Time square. Dimension is 0. So k is dimensionless. K is a dimensionless value. Yes. K is dimensionless. Answer is 5. Question number 2. Centripetal acceleration of particle which is moving in a circular path with a uniform angular velocity of omega is simple f. The graph between omega and f correctly represented. So we know omega is given by 2 phi f. 2 phi f. So graph between omega and f must be shape of y equals mx. Omega in y axis, f in x axis. Answer is 2. Question number 3. Next week, ever put up 1 hour later, calling in a plan 3. No. Again, 3 to 4 වෙනකම් මම කියනවා මේ paper එකක් MCQ paper එකක් ලියන්න පුළුවන් 3 to 4. එතන අපි අන්තිම මේකේ කරමු. ඊට කලින් ගත්තොත් මම paper එක ලියන්න. නෑ. එහෙනම් අපි 3 එන්න පුළුවන්. අමම. බෑ. පුළුවන්ද? ස්කෝල් එකක් තියෙනවා. आपने दिया है मैसेज डाल सकता क्वेश्चन नंबर 3 है ना बड़ा प्रिपेयर वाला है ना 25 MCQs 1 hour 25 MCQs देना में Sunday evening classes थी नहीं ना Sunday evening Right. The combined mass of ride and motorcycle is 200 kilograms. What is the necessary frictional force if the rider is to negotiate a curve of 80 meters radius at speed of 72 kilometers per hour? Necessary frictional force the frictional force should be equal to the centripetal force mv squared over r. Circular motion 200 v is 72. Convert that into meters per second, which is 20 square. The radius is 80 meters. Thousand newtons. 1000. Third answer is 3. No. Ticket of class start करना डेट है क्या altitude डेट है again available done don't any Sunday house available house and is they class start करना होता है सर या करने पे again sir and Sunday evening for house not there after program तो ये ना तो start करना बोला तो वहाँ मार्च चली ना हमारी क्लास से पेपर क्लास से स्टार्ट करना है इधर संडे बंद किया है right question number 4 a ball is projected vertically upwards with a certain initial speed. Another ball of the same mass is projected at angle 60 with the vertical line with same initial speed. At the highest point, the ratio of the potential energies. Right, at the highest point, what is the ratio of potential energies. Right. So maximum height of the body one. එයා මොකද කරලා තියෙන්නේ? එයා vertically upward යන්නේ. Same speed ද කියන්නේ? Certain initial speed නේද? Speed එක. So maximum height is given by u squared over 2g. Right? Motion on the gravity u squared h1 කියලා කියමු. Right. So potential energy E1 is mgh1 for this motion. The maximum height for the projectile h2 is given by u squared sine squared theta over 2g. Angle is 60. So potential energy at the maximum height for the projectile is mgh2. The ratios of E1 and E2, mg cancels. So equal to ratio of h1 h2. So the h1 has u squared over 2g term. H2 also have the same term. Right? When you get the division of these two h1 and h2, the remaining is 1 over sine squared 60. So what is sine 60? Root 3 over 2 square 3 over 4. So ratio of potential energy is 4 to 3. Answer correct? I'm gonna add it. ये कितना 2 3 කියලා නම් තියෙනවා. බලන්න හරිද බයල ගන්නද? මෙතන maximum energy එක එනවා height එකේදී. This is not sorry. Sine 60 නෙවෙයි. The velocity at the maximum height it has the horizontal component එකක් තියෙන්නේ. What solution නේද? ඒ particle energy ගන්නේ. Maximum height එක වෙන්නේ තමයි. Maximum height එක ඉස්සරහේ. Initial velocity is u, angle 60, the maximum height h1. Initial, the vertical component is u sine 60. U is right, b square 0, u square is u sine 60 square minus 2g h2. මේක තමයි හරි. පයින්ටි කැලේ ටිකක් තමයි අවුලේ. chance එකක් නැහැ නේ. ඒක 43 කරගමු නේද අපි third එක. කවදාද මේ හදාගන්නේ 43 කරගන්න. values වල වෙනසක් නැහැ. 43 කරගන්න. Right, fifth question. A sphere of mass 2 kilograms is moving towards east. 2 kg moving towards east with velocity 4 meters per second. Another sphere of mass 3 kilograms is moving towards the north. Another one moving towards the north. 3 kilograms. 6 meters per second. The two spheres collide each other, combine and move together after collision. They collide and combine and move together after collision. When you see the two velocities, direction of two velocities after the collisions, this combined body should have a velocity along this direction and also velocity along the east. East and north velocities දෙකක් තියෙනවා. The angle between east and the direction of motion. Question asks about this direction. Right. apply conservation of linear momentum to the east. Initially, the momentum of 2 kilograms to the east is 2 into 4. Momentum of 3 is 0. After combine, the total mass is 2 into 3. Velocity is v2. 2 by 4 is 8. So v2 is 8 over 5. From the conservation of linear momentum, the initial momentum of 2 kg is 0 to the north. 3 kg is 3 into 6 to the north. The final mass is 2 plus 3. Velocity is v1. 18 over 5, v2. The question asks about theta. The tan theta equals v1 over v2. So v1 is 18 over 5. v2 is 8 over 5. Tan theta is 18 divided by 18. 8. 18 divided by 8. 9 over 4. Theta is tan inverse 9 over 4. Fifth one. Answer is what? तो मैं पे बैक करांगे नेक्स्ट वीक के नेक्स्ट वीक काफी सर्कुलर मोशन वाला පොඩි කැලකින් එටික ඉවර කරනවා ඊට පස්සේ center of mass වලින් පස්සේ yeah let's start 3 to 8:30 තමයි යාලගේ වැඩේන පොඩ්ඩක් නෑ ඔයගොල්ලෝ ඉවරට කලින් ඔයාලට නියෝඩ්ලස් වෙනසක් අපිට කරන්න පුළුවන් මේකේ ක්ලාස් එක එක්ස්ට්‍රා ක්ලාස් යන්නේ 3 to 9 man 3 to 9 yeah 8 to 9 paper එක ලියමු ඔව් 3 ඉඳන් අපි මේ theory ස්ටාර්ට් කරමු තාප අන්තිම ටික ලියමුනේ ආපු ගම ලියුවොත් එහෙම නිකන් අවුල්නේ පොඩ්ඩක් පේපර් එකක් ලියනවා ඉතින් අද 8:30 9:30 message එකේ තිබ්බ තාත් ඉවරද තියෙනව නේද message එක මම කියවනේ 8:30 ඔව් හරි එහෙනම් මේ next week එන්න මේ center of gravity අර questions අපිට ඉතුරුලා දෙන්න ඉවර කරන්න ඔක්කොම ටික past chemistry ඉවර කරන්න next week එකේ circular motion ඉවර කළා rotational motion start කරනවා moment of inertia එක start කරනවා next week එකේ හරි එහෙනම් good night ආයිබෝන්